A transatlantic telegraph cable is an undersea cable running under the Atlantic Ocean used for telegraph communications. The first was laid across the floor of the Atlantic from Telegraph Field, Foilhommerum Bay, Valentia Island in Western Ireland to Heart's Content in eastern Newfoundland. The first communications occurred August 16, 1858, reducing the communication time between North America and Europe from 10 days the time it took to deliver a message by ship to a matter of minutes. Transatlantic telegraph cables have been replaced by transatlantic telecommunications cables. Early history: in the 1840s and 1850s several individuals proposed or advocated construction of a telegraph cable across the Atlantic Ocean, including Edward Thornton and Alonzo Jackman. Cyrus Westfield and the Atlantic Telegraph Company were behind the construction of the first transatlantic telegraph cable. The project began in 1854 and was completed in 1858. The cable functioned for only 3 weeks, but it was the first such project to yield practical results. The first official telegram to pass between two continents was a letter of congratulation from Queen Victoria of the United Kingdom to the President of the United States James Buchanan on August 16. Signal quality declined rapidly, slowing transmission to an almost unusable speed. The cable was destroyed the following month when Wildman Whitehouse applied excessive voltage to it while trying to achieve faster operation. It has been argued that the faulty manufacture, storage and handling of the 1858 cable would have led to premature failure in any case. The cable's rapid failure undermined public and investor confidence and delayed efforts to restore a connection. A second attempt was undertaken in 1865 with much improved material and, following some setbacks, a connection was completed and put into service on July 28, 1866. This cable proved more durable. Before the first transatlantic cable, communications between Europe and the Americas took place only by ship. Sometimes, however, severe winter storms delayed ships for weeks. The transatlantic cable reduced communication time considerably, allowing a message and a response in the same day. 5 attempts to lay a cable were made over a 9-year period, one in 1857, 2 in 1858, 1 in 1865, and 1 in 1866. Lasting connections were finally achieved with the 1866 cable and the 1865 cable, which was repaired by Sambard Kingdom Brunel's ship the SS Great Eastern, captained by Sir James Anderson. In the 1870s duplex and quadruplex transmission and receiving systems were set up that could relay multiple messages over the cable. Additional cables were laid between Foilhommerum and Heart's Content in 1873, 1874, 1880, and 1894. By the end of the 19th century, British, French, German, and American-owned cables linked Europe and North America in a sophisticated web of telegraphic communications. Origins of the idea. William Cooke and Charles Wheatstone introduced their working telegraph in 1839. As early as 1840 Samuel F. B. Morse proclaimed his faith in the idea of a submarine line across the Atlantic Ocean. By 1850 a cable was run between England and France. That same year Bishop John T. Mullock, head of a Roman Catholic church in Newfoundland, proposed a telegraph line through the forest from St. John's to Cape Ray, and cables across the Gulf of St. Lawrence from Cape Ray to Nova Scotia across the Cabot Strait. At about the same time a similar plan occurred to Frederick Newton Gisborne, a telegraph engineer in Nova Scotia. In the spring of 1851, Gisborne procured a grant from the legislature of Newfoundland and, having formed a company, began the construction of the landline. In 1853 his company collapsed, he was arrested for debt and he lost everything. The following year he was introduced to Cyrus Westfield. Field invited Gisborne to his house to discuss the project. From his visitor, Field considered the idea that the cable to Newfoundland might be extended across the Atlantic Ocean. Field was ignorant of submarine cables in the deep sea. He consulted Morse as well as Lieutenant Matthew Maury, an authority on oceanography. Field adopted Gisborne's scheme as a preliminary step to the bigger undertaking, and promoted the New York, Newfoundland and London Telegraph Company to establish a telegraph line between America and Europe. St. John's to Nova Scotia. The first step was to finish the line between St. John's and Nova Scotia, and in 1855 an attempt was made to lay a cable across the Cabot Strait in the Gulf of St. Lawrence. It was laid out from a bark in tow of a steamer. When half the cable was laid, a gale rose, and the line was cut to keep the bark from sinking. The next summer a steamboat was fitted out for the purpose, and the link from Cape Ray, Newfoundland to Asby Bay, Nova Scotia was successfully laid. Transatlantic. With Charles Tilston Bright as chief engineer, Field then directed the transoceanic cable effort. A survey was made of the proposed route and showed that the cable was feasible. Funds were raised from both American and British sources by selling shares in the Atlantic Telegraph Company. Field himself supplied a quarter of the needed capital. The cable consisted of 7 copper wires, each weighing 26 kilograms per kilometer, covered with 3 coats of gutta percha, weighing 64 kilograms per kilometer, and wound with tarred hemp, over which a sheath of 18 strands, each of 7 iron wires, was laid in a close spiral. It weighed nearly 550 kilograms per kilometer, was relatively flexible and was able to withstand a pull of several tens of kilonewtons. It was made jointly by 2 English firms, Euroglass, Elliott and Company, of Greenwich, and Oresnawall and Company, of Birkenhead. Late in manufacturing it was discovered that the respective sections had been made with strands twisted in opposite directions. While the 2 sections proved a simple matter to join, this mistake subsequently became magnified in the public mind. The British government gave Field a subsidy of £1,400 a year and loaned the ships needed. Field also solicited aid from the U.S. government. A bill authorizing a subsidy was submitted in Congress. The subsidy bill passed the Senate by a single vote, due to opposition from Anglophobe senators. In the House of Representatives, the bill encountered similar resistance, but passed, and was signed by President Franklin Pierce. The first attempt, in 1857, was a failure. The cable-laying vessels were the converted warships HMS Agamemnon and USS Niagara. The cable was started at the White Strand near Ballycarberry Castle in County Kerry, on the southwest coast of Ireland, on August 5, 1857. The cable broke on the first day, but was grappled and repaired. It broke again over the Telegraph Plateau, nearly 3,200 m deep, and the operation was abandoned for the year. The following summer, after experiments in the Bay of Biscay, Agamemnon and Niagara tried again. The vessels were to meet in the middle of the Atlantic, where the 2 halves of the cable were to be spliced together, and while Agamemnon paid out eastwards to Valentia Island, Niagara was to pay out westward to Newfoundland. On June 26, the middle splice was made and the cable was dropped. Again the cable broke, the first time after less than 5.5 kilometers, again after some 100 kilometers, and for a third time when about 370 kilometers of cable had run out of each vessel. The expedition returned to Queenstown, and set out again on July 17, with little enthusiasm among the crews. The middle splice was finished on July 29, 1858. The cable ran easily this time. Niagara arrived in Trinity Bay, Newfoundland on August 4 and the next morning the shore end was landed. Agamemnon made an equally successful run. On August 5, she arrived at Valentia Island, and the shore end was landed at Nicetown and then laid to the nearby cable house. First contact. On August 16, 1858 the first message sent via the cable was, "Europe and America are united by telegraphy. Glory to God in the highest. On earth, peace and goodwill toward men." Queen Victoria then sent a telegram of congratulation to President James Buchanan at his summer residence in the Bedford Springs Hotel in Pennsylvania and expressed a hope that it would prove an additional link between the nations whose friendship is founded on their common interest and reciprocal esteem. The President responded that, "It is a triumph more glorious, because far more useful to mankind, than was ever won by conqueror on the field of battle. May the Atlantic Telegraph, under the blessing of heaven, prove to be a bond of perpetual peace and friendship between the kindred nations, and an instrument destined by divine providence to diffuse religion, civilization, liberty, and law throughout the world." The messages were hard to decipher. Queen Victoria's message of 98 words took 16 hours to send. These messages engendered an outburst of enthusiasm. The next morning a grand salute of 100 guns resounded in New York City, the streets were decorated with flags, the bells of the churches were rung, and at night the city was illuminated. Failure of the first cable. The operation of the new cable was plagued by the fact that the two senior electrical engineers of the company had very different ideas on how the cable should be worked. Lord Kelvin and Dr. Wildman Whitehouse were located at opposite ends of the cable, communicating only by the cable itself. Kelvin, located at the western end, believed that it was necessary to employ only a low voltage and to detect the rising edge of the current flowing out of the cable and, once this had been done, nothing would be gained by further monitoring. Kelvin invented his mirror galvanometer precisely for this task of observing the current change quickly. At the eastern end of the cable was Whitehouse. He was the company's chief electrician and a doctor of medicine. Any electrical knowledge that he possessed was self-taught. Whitehouse believed that, in order to have the current at the receiving end change as rapidly as possible, the cable should be driven from a high-voltage source. The position was made worse because every time intelligible Morse code was seen on the mirror galvanometer at the eastern end, Whitehouse insisted that the galvanometer be disconnected and replaced with his own patented telegraph recorder, which was far less sensitive. The effects of the poor handling and design of the cable, coupled with Whitehouse's repeated attempts to drive the cable with high voltages, resulted in the insulation of the cable being compromised. All the while, it was taking longer and longer to send messages. Towards the end, sending half a page of message text was taking as long as a day. In September, after several days of progressive deterioration of the insulation, the cable failed. The reaction to this news was tremendous. Some writers even hinted that the line was a mere hoax, and others pronounced it a stock exchange speculation. In the inquiry that followed, Dr. Whitehouse was deemed responsible for the failure, but the company did not escape criticism for employing an electrical engineer with no recognized qualifications. Field was undaunted by the failure. He was eager to renew the work, but the public had lost confidence in the scheme and his efforts to revive the company were futile. It was not until 1864 that, with the assistance of Thomas Brassey and John Pender, he succeeded in raising the necessary capital. The Glass, Elliott, and Gutta Percha companies were united to form the Telegraph Construction and Maintenance Company, which undertook to manufacture and lay the new cable. Compare Varley replaced Whitehouse as chief electrician. In the meantime, long cables had been submerged in the Mediterranean and the Red Sea. With this experience, an improved cable was designed. The core consisted of 7 twisted strands of very pure copper weighing 300 pounds per nautical mile, coated with Chatterton's compound, then covered with 4 layers of gutta percha, alternating with 4 thin layers of the compound cementing the whole, and bringing the weight of the insulator to 400 pounds me. This core was covered with hemp saturated in a preservative solution, and on the hemp were spirally wound 18 single strands of high-tensile steel wire produced by Webster and Hosful Limited of Hay Mills, Birmingham, each covered with fine strands of manila yarn steeped in the preservative. The weight of the new cable was 35.75 long hundredweight per nautical mile, or nearly twice the weight of the old. The Hay Mills site successfully manufactured 30,000 miles of wire, made by 250 workers over 11 months. Repairing the cable, broken cables required an elaborate repair procedure. The approximate distance to the break is determined by measuring the resistance of the broken cable. The repair ship navigated to the location. The cable was hooked with a grapple and brought on board to test for electrical continuity. Buoys were deployed to mark the ends of good cable and a splice was made between the two ends. Great Eastern. The new cable was laid by the ship Great Eastern, captained by Sir James Anderson. Her immense hull was fitted with 3 iron tanks for the reception of 2,300 nautical miles of cable, and her decks furnished with the paying out gear. At noon on July 15, 1865, Great Eastern left the Nore for Foilhommerum Bay, Valentia Island, where the shore end was laid by Caroline. This attempt failed on July 31 when, After 1,062 miles had been paid out, the cable snapped near the stern of the ship, and the end was lost. Great Eastern steamed back to England, where Field issued another prospectus, and formed the Anglo-American Telegraph Company, to lay a new cable and complete the broken one. On July 13, 1866, Great Eastern started paying out once more. Despite problems with the weather on the evening of Friday, July 27, the expedition reached the port of Heart's Content in a thick fog. The next morning at 9 a.m., a message from England cited these words from the leader in the Times: "It is a great work, a glory to our age and nation, and the men who have achieved it deserve to be honored among the benefactors of their race." Treaty of peace signed between Prussia and Austria. The shore end was landed during the day by Medway. Congratulations poured in, and friendly telegrams were again exchanged between Queen Victoria and the United States. On August 9 Great Eastern put to sea again, in order to grapple the lost cable of 1865, and complete it to Newfoundland. They were determined to find it. There were some who thought it hopeless to try, declaring that to locate a cable 2.5 miles down would be like looking for a small needle in a large haystack. Robert Halpin navigated the ship to the correct location. For days, Great Eastern moved slowly here and there, fishing for the lost cable with a grappling hook at the end of a stout rope. Suddenly, the cable was caught, and brought to the surface, but while the men cheered it slipped from the hook and vanished again. It was not until a fortnight later that it was once more fished up. It took 26 hours to get it safely on board Great Eastern again. The cable was carried to the electrician's room, where it was determined that the cable was connected. All on the ship cheered or wept as rockets were sent up into the sky to light the sea. The recovered cable was then spliced to a fresh cable in her hold, and paid out to Heart's Content, Newfoundland, where she arrived on Saturday, September 7. There were now 2 working telegraph lines. Communication speeds: initially messages were sent by an operator sending Morse code. The reception was very bad on the 1858 cable, and it took 2 minutes to transmit just 1 character, a rate of about 0.1 words per minute. This is despite the use of a highly sensitive mirror galvanometer, a new invention at the time. The first message on the 1858 cable took over 17 hours to transmit. For the 1866 cable, the methods of cable manufacture, as well as sending messages, had been vastly improved. The 1866 cable could transmit 8 words a minute, €80 times faster than the 1858 cable. Heaviside and Mihailo Idvorsky-Pupin in later decades understood that the bandwidth of a cable is hindered by an imbalance between capacitive and inductive reactance, which causes a severe dispersion and hence a signal distortion. See telegraphers' equations. This has to be solved by iron tape or by load coils. It was not until the 20th century that message transmission speeds over transatlantic cables would reach even 120 words per minute. Despite this, London had become the world centre in telecommunications. Eventually, no fewer than 11 cables radiated from Porthcurno Cable Station near Land's End and formed with their Commonwealth links a live girdle around the world. Repeater equals, the original cables were not fitted with repeaters, which would have amplified the signal along the way, because there was no practical way to power the relays. As technology advanced, intermediate relays became possible. In fiction, the cable is one of the many underwater landmarks observed by the Nautilus and Jules Vernier unregistered trademark S 20,000 Leagues Under the Sea. The 2003 novel Signal and Noise, by John Grierson, tells a fictionalized story of the project, including many incidents from real life. In the novel Open the Door, by Catherine Carswell, the Bannermans visit the Great Eastern, which lay in Liverpool Harbour as a show ship before being broken up. Lynette Bannerman's imagination has been captured by the cable. Hans Christian Andersen's story The Great Sea Serpent describes the havoc and confusion among the sea dwellers caused by the laying of the cable. See also, Robert Halpin, a Euro captain of the Great Eastern, Transatlantic telephone cable, Western Union Telegraph Expedition, a Euro overland alternative via Russia, 1929 Grand Banks earthquake, Commercial Cable Company. Enderby's Wharf. Notes. This article incorporates text from a publication now in the public domain, Chisholm, Hugh, ed. Encyclopædia Britannica. Cambridge University Press. References and further reading, Clarke, Arthur C. Voice Across the Sea and How the World Was Won. The two books include some of the same material. Gordon, John Steele. A Thread Across the Ocean, The Heroic Story of the Transatlantic Cable. New York, Walker and Colorado, 2002. ISBN 978-0-8027-1364-3. Murray, Donald. How Cables Unite the World. The World's Work, A History of Our Time 2, 2298 to €2309. Retrieved July 9, 2009. Rozadowski, Helen. Fathoming the Ocean. Devotes a good deal of space to the description of cable laying. Standage, Tom. The Victorian Internet. ISBN 0-7538-0703-3. The story of the men and women who were the earliest pioneers of the online frontier, and the global network they created, a network that was, in effect, the Victorian Internet. Cookson, Gillian. The Cable. 2nd ed., Tempest Publishing. ISBN 0-7524-3903-0. External links. The Atlantic Cable by Bernd Dibner, a complete free electronic version of The Atlantic Cable by Bernd Dibner, hosted by the Smithsonian Institution Libraries, History of the Atlantic Cable and Undersea Communications, a comprehensive history of submarine telegraphy with much original material, including photographs of cable manufacturers' samples, PBS, American Experience, The Great Transatlantic Cable, The History Channel, Modern Marvels, Transatlantic Cable, 2,500 Miles of Copper, a collection of articles on the history of telegraphy, Cabot Strait Telegraph Cable 1856 between Newfoundland and Nova Scotia, American Heritage, The Cable Under the Sea. Alan Hall, First Transatlantic Cable and First Message Sent to USA 1856 Memorial, Travelogue Around the World's Communications Cables by Neil Stevenson, The Old Cable House, Atlantic Telegraph Cable 150th Anniversary 1858 to 2008. ICPC International Cable Protection Committee, IEE History Center, County Kerry Transatlantic Cable Stations, 1866, IEE History Center, Landing of the Transatlantic Cable, 1866, The Telegraph Field, Valentia Island, Laying of the Atlantic Cable, The Great Eastern, Robert Dudley Lithographs 1865, Special Service in commemoration of the laying of the Atlantic Ocean Telegraph, Trinity Church, New York, September 1, 1858. Reconstructed and digitized by Cynthia McFarland and Richard Mamana, 2011.